Assalamualaikum and hi everyone. So in this video I will teach you about solving differential equation by using linear equation. So in order to use a linear equation, first the differential equation of first order must be in form of linear. So what I mean by linear is this must be in term of this general form. So look at this general form. So we have ax dy over dx plus bx multiply y equal to cx. So when we set a linear, the dependent variable, which is y, must be in terms of power must be equal to 1 only. So here the derivative of y, which is dy over dx, the power is 1, and also the variable y, the power is 1. If we have dy over dx, where this derivative is 2, then this is not a linear equation. Also, when you have this variable y here, the power is greater than 1. For example, y to the power 2 or y to the power 3, or maybe you have non-linear term, for example, exponent y or sine y. All these terms are not linear. Hence, we cannot consider to solve the differential equation consists of this term by using linear equation. This is not applicable. You cannot use a linear equation to solve a differential equation if you see any term of dependent variable y squared, y cubed, exponent y, sine y, or whatever term that is not a linear. So this one already power 1, here is also power 1, then this is a linear equation. So now when you confirm that the differential equation is a linear equation, then we can proceed to the methods of solution. First one is to reform the given linear equation in the standard form. The standard form means when you have the coefficient for the derivative here supposed to be 1. So what you need to do is you have a coefficient, for example like this, in front of the derivative dy dx. So you need to divide every term with the function ax. So divide here with ax, bx with ax, cx with cx with ax. Hence this one will be 1, bx over ax will be px, cx over ax will be qx, new function. Then calculate the integrating factor mu x. So mu x, the integrating factor, you take it from the coefficient of variable y. So you take here as px, and then to find integrating factor, mu x equal to exponent of px, integrations of px with dx. So you need to integrate the px. No need to put the constant of integration c. Just write the answer, and no need to write to constant of integration c. Step number 3, multiply both sides of standard equation, standard form with integrating factor. So after you have calculate the integrating factor, you multiply both sides of a standard form with this integrating factor. So you multiply mu x with dy dx, mu x with pxy, mu x with qx. So after you have multiplied everything with integrating factor, the left hand side here, you can simplify by using this one. D over dx equal to mu x multiply y. And the right hand side still left with mu x qx. So now you observe that actually if you differentiate this term here, you will exactly get the second term when you multiply with the mu x. So this one, because we have a derivative here, so to get rid of this derivative, we integrate here when we integrate here, that means because we have a equal sign here, this side also you must integrate. So integrate both sides of equation. That means when we integrate here, we get rid of d over dx. So you have mu x multiply y. And this one, you should integrate this one plus c. So after you have integrate this one, this side plus c, now divide everything by mu x. So you have a function of in term of y only. After you get the solution, simplify the general solution. If given condition, find the particular solution. So find c if we are given the condition. That is all the steps to solve a linear equation. Alright, let's see this example. Solve dy over dx minus 3y equal to 6. So this is already in linear form. Dy dx, the highest power is 1. 3y, y is the power 1. So this is a linear equation. So to solve this one, we need to find the integrating factor mu x. So mu x equal to exponent px dx. So here our px is negative 3. Negative 3 is our px. Coefficients of y. So we have exponent integration of negative 3 with respect to dx. So when we integrating with respect to dx, that means we will get the answer in terms of variable x. So we have exponent negative 3x. No need to put the constants of integration here. Alright, multiply everything with mu x. So we have exponent negative 3x multiply dy over dx minus 3 y exponent negative 3x equal to exponent negative 3x multiply 6. So the left hand side here, this one can be reduced to d over dx mu x y. Our mu x is exponent negative 3x y. Right hand side, exponent negative 3x multiply 6. And then integrate both sides. So to integrate both sides, we have exponent negative 3x y equal to integrations of 6 exponent negative 3x. So integrate exponent negative 3x, 6 outside, exponent negative 3x divided by negative 3 plus c. So we have negative 2 exponent negative 3x plus c. So now express this solution in terms of y. So y equal to negative 2 exponent negative 3x divided by exponent negative 3x plus c divided by exponent negative 3x. So exponent negative 3x divided by exponent negative 3x equal to 1. So we have negative 2 plus c, and then this one we can put upside, so the power of negative will be positive. So this is our final answer. Negative 2 plus c exponent negative exponent 3x. Alright, example number 7. Solve x dy over dx minus 4y equal to x to the power of 6 exponent x. So this is a linear equation but not in standard form because we have a coefficient in front of dy over dx. So divide everything by x. So we have dy over dx minus 4 over xy equal to x to the power of 5 exponent x. So now what is our px here? Px is negative 4 over x. So find the integrating factor. Mu x is exponent px dx. So exponent negative 4 outside 1 over x dx. So we get exponent negative 4 ln x dx, which is ln x to the power negative 4, which is exponent. Here we have negative 4. Multiply everything with exponent. Multiply everything with mu x negative x negative 4, so we have x negative 4, which is I like to write this one as 1 over x to the power of 4 dy over dx minus 4 over x 1 over x to the power of 4 y equal to x to the power of 6 exponent x divided by x to the power of 4 x to the power of 5, sorry, x to the power of 5 exponent x divided by x to the power of 4. Alright, so the left hand side will be d over dx 1 over x to the power of 4y. Right hand side will be x exponent x. So integrate both sides. So we have y over x to the power of 4 equal to integration x exponent x. So to find the integration for x exponent x, we will use the integration by tabular method. So to use the integration by tabular method, please remember this this term I late. So I is for inverse trigonometry, L is for log, logarithm, log or ln, A is for algebraic, T is for trigonometry, E is for exponent. So this is how you can rearrange to solve for tabular method. So in tabular method, you need to have first term for differentiate, second term for integrate. The more to the left goes to the differentiate. For example, here we have x exponent x. So x is the algebraic term, exponent is this term. That means the exponent will goes to the integrate, while a will go x will goes to the differentiate. So here I will put x, here I will put exponent x. So to differentiate, you must differentiate the terms until 0. So differentiate x, you get 1, differentiate 1, you get 0. Do this accordingly to the integration. So integrate exponent x, so we get exponent x, also integrate one more time, also exponent x, and then x multiplied by exponent x, this one multiply this one, and put the sign, alternate sign, positive, negative, positive. So what is this answer? So positive x multiply exponent x, so x exponent x minus exponent x. So this is our answer for the integration of x exponent x. So we take this answer to this one. So this one, the answer is x exponent x minus minus exponent x. So y will be multiply with x to the power 4, so x to the power of 5 exponent x minus x to the power of 4 exponent x. And don't forget, actually this one consists of the constants of integration, so we have c x to the power of 4. So this is our answer. Let's see example number 8. Find a particular solution for dy over dx plus y equal to x. Alright, to solve for this one, find the integrating factor mu x. So this is already in standard form, so mu x exponent integration of px with respect to dx. So here our px is 1 multiply y, so integrations of 1 with respect to x, so we have exponent x. So multiply each term with exponent x, so exponent x dy over dx plus exponent xy equal to exponent x. The left hand side can be reduced to d over dx, exponent x multiply y. Right hand side will be exponent x multiplied by x. Alright, so integrate both sides. So we have exponent x y equal to integration of x exponent x. So this one we already find the solution by using tabular method, which is equal to x exponent x minus exponent x. Hence y equal to, divide everything by exponent x. Don't forget plus constant of integration c. So x exponent x divided by exponent x minus exponent x divided by exponent x plus c divided by exponent x. So we have x minus 1 plus c exponent negative x. So this one is general solution. To find particular solution, substitute the condition given. Here mean when x equal to 0, y equal to 4. So when x equal to 0, y equal to 4, so 4 equal to 0 minus 1 plus exponent 0 is 1, so plus c. So c equal to 4 plus 1, 5. Hence the general solution, the particular solution is x minus 1 plus 5 exponent minus x. So that is the answer, the final answer. Alright, you may do this exercise 2.3, do the odd question only. Is that, thank you.